And we are back with more CLEP calculus practice questions. This is another batch that I found directly on CLEP's website at this URL. It's not even a PDF, it's just directly on the web. So I printed that out so we can start going through them. And, well, this first one I formatted for the web a little bit, so let's rewrite it in a more traditional form. Natural log of pi over x minus pi. And, if we got a real, actual calculus professor, maybe he could tell us the rigorous way to approach this. Obviously, as x approaches pi, that becomes 0 and that becomes 0. You get 0 over 0. So we can't glean anything that way exactly. As you get close to 0, obviously you have a small number there. But as this becomes close to 0, it's going to be an even smaller number because you're taking the natural logs, which makes them smaller. When that equals that, it becomes 0. But as it's getting closer to 0, it's going to the top is going to be a much smaller number than the bottom. So that suggests it's some kind of fraction. And the only two options with fractions are b and d. And, d is kind of complicated and b is simpler. So maybe our instincts say, go with the simpler one. I really don't have any better justification for it than that. Definitely, if you run it through the calculator, it does turn out that is the actual answer. And there's nothing special about the pi. You could put in any number for that pi. It could be 1, 5, 10, whatever. This still works. So it's like some special property of this arrangement with the natural log here. But that's one of those goofy limit things that there isn't really a good way to approach it. And really, if you leave that one to skip and come back to, or just literally skip it entirely, I wouldn't blame you for that at all. So let's move on then to number 2. And I will rewrite it into a little more traditional format instead of the flat web page format that they were kind of squished into there. So limit as x approaches 1 for this. Now, this looks like something we can simplify out a little bit, right? So 1 minus x squared. Now remember that when you're subtracting a square, when you have a square minus a square, we can simplify that to 1 plus x times 1 minus x, right? Because those multiplied together get you 1 squared minus x squared. And then on the bottom, we can just pull out an x, right? So you get x minus 1. And, we want to have something to cancel out here. None of these things really match, except we do have a 1 minus x and an x minus 1. And boy, those are really close to each other. Wouldn't it be nice? And in fact, we can if we just pop out a negative, if we factor out a negative 1. So we have a negative 1, 1 plus the x. And by factoring out that negative 1, we now transform this into x minus 1, because if we multiplied that through there, we would have negative x plus 1. So we can just pop that out. And now it's the same as on the bottom. And we can cancel those out. And it's basically negative x plus 1 over x. And now, as x approaches 1, we can just say negative 1 plus 1 over 1, and that's just -2. And -2 is right there in our choices. So that is the answer. So we went from a really almost impossible kind of limit question to one that we can reach just an actual value just by doing some fairly simple factoring. And that seems to be the nature of those limit questions. Either they're workable or they're just really, really difficult to at least to do by hand without running the numbers on it. Like with with a calculator, you wouldn't want to do it by hand. Okay. So number 3 here, and we just want the indefinite integral. There's no numbers here, so it's just integrate this, right? And we're gonna, it's the square root of x minus 5 over x plus e to the x. Or in order to integrate it, we want to call it x to the half minus 5x to the -1, because it's on the bottom, so we bring it up to the top by making the exponent negative, and then e to the x. So we integrate that. Again, we subtract 1 from the exponent to take the derivative, so we're going to add back 1 to it. And then going from here to here, we would have to bring that exponent down in front, multiply, but there's nothing there, so we have to add something that cancels it out, which is just the reciprocal. So 2/3, and when we bring the 3/2 down, they cancel each other out. You subtract 1 from the 3/2, you get the 1/2, which becomes the square root. And then we kind of do the same thing here, where we have the x, and we subtracted 1 to get to there. So, well, you can't do that, but recall that what derivative ends up being 1 over x, and that's the log of x, because otherwise you'd be starting from 0, and you can't do that. So that's the log of x, and then the 5 is just hanging out, and then e to the x is always its own derivative, making it its own integral. And don't forget the c, although if you do, every possible answer has the c, so that's not even part of the question here. But we can see what we've done matches b. Even just having the first part narrows it down, but then having the natural log of x in the middle tells us that it is b. Okay. Let f be a differentiable function such that at x equals 1, the function equals 10, and the derivative, it's hard to see, but there's a tick mark there, so that's the derivative. The derivative equals the square root of x to the 3rd plus 15. So what is the approximation of the function at x equals 1.2 found by using the line tangent to the graph? So this is one of those where we're going to pretend that we don't know how to find this the real way, and we're going to kind of get an approximation by doing something simpler. So it's the square root of something, so it probably goes like that somehow. And at x equals 1, it's got some slope to it, and so at x of 1.2, the real value is here, But if you look on this line, that's pretty close. You know, the error is that much, and we're going to say that's not enough to worry about. So we are asking, what is that value there? What is the y value at that point? So we know that this is xy coordinates 110. And so we want to know what is the slope of this line at x equals 1. So we just fill that in. Square root of 1 cubed plus 15 equals, 1 cubed is still 1, equals square root of 16 equals 4. So this has a slope of 4. And so for every 1x, we go that way, we go up by 4. But we're only going over by 0.2. We're going from 1 to 1.2. So we're only going over by 0.2. So we're going up by whatever 0.2 times 4 is, and that's going to be 0.8. So we're going to go up by 0.8, and we're going up from where? We're going up from 10, because we're starting at those coordinates 1 and 10. So we're going up to value of 1.2, and 10 plus 0.8 is 10.8. That gives us D. That is indeed the answer. Okay, next one. The function of f is the natural log of sine of x plus 1. I smell a chain rule coming on. What is the slope of the line tangent to the graph, meaning what is the derivative at x equals 0? So we need to find the derivative and then plug in 0 for x and find out what that is. So we're doing chain rule here. So remember that the chain rule says when we start with f of x of g, a thing inside of another thing, that the derivative is the derivative of f with the original g in it multiplied by the derivative of the g. So in this case, our f is the natural log, which means the derivative of f is 1 over x, and our g is the sine of x plus 1, which means our derivative of g. Now remember, the derivative of the sine is just the cosine. So that's the cosine of x, and then the plus 1 being a constant, the derivative of that is 0, it just goes away. So that's all we need to know. Now we plug it into there. So we have 1 over the original g, so 1 over sine of x plus 1 times the derivative of the g, which is the cosine of x. So I'll just write it up here right away. Cosine of x. So what is this at x equals 0? So now remember again our unit circle. We're at angle of 0, and remember that the sine of theta is the y and the cosine of theta is the x. So because we're at an angle of 0, we have the x value is 1 and the y value is 0. So this resolves to 1 over 0 plus 1, and that's just 1 over 1 is just 1, and indeed the answer is D. And we will do the rest in the next video.